agentically coding with small large language models. And when I say small, I mean between 3 and 14 billion parameters. This is a rabbit hole I've been diving down for the past few weeks, and I started the journey when I downloaded Google Anti-Gravity. I was hooked. What do you mean I can talk to my computer and it's going to write Python script for me? Ooh, ooh. Thank you very much, Google. So I played around with it, and after a couple of days of playing around with it and researching how to use anti-gravity on YouTube, I found out about the Ralph loop. And the Ralph loop is basically a while loop that you place an agent into to reach a goal. On the left, we have a route loop. Let's go over and let's zoom in a little bit here. We start our loop with a state. That state might be create a Python script to monitor this network port. During our loop, we tell Ralph to write the code to achieve that state. Ralph writes the code, and during that process, it tests and validates the code it writes. If it runs into any errors, it goes back and runs through the loop again. So the Ralph loop is effectively a REPL loop. It's basically a read, eval, print loop. Ralph is read, eval, print. I thought this was pretty cool, but after enabling the route loop inside of Google Anti-Gravity, I ran into an issue that apparently developers have been running into for the past year or so, and that is quota. It turns out the pro version of Gemini, when you enable Ralph loop without some context summarization, will very quickly run through your quota, like within 20 minutes if you have it trying to achieve a specific goal and you're not watching it, right? And I was like, well, what if I could just have my local LLM go into the Ralph loop and do the heavy lifting for most of this code, and then just have anti-gravity kind of watch things, be the manager, and then my local GPU that's slower can do the, heavy lifting. And I can save some token costs and get even more work done. Great idea in principle. Have a smaller model do the coding and have Ralph manage its prompts, and you could kind of have them feed back to each other until you get a working result. Where Gemini or anti-gravity is monitoring Ralph's work and keeping an eye on it to ensure that it completes its tasks. Keyword there being in principle. I try to use different solutions like Claude Code, Open Code. I think it was called Kilo Code, for me to integrate a small large language model, something less than 14 billion parameters, something that could actually run at a decent speed, into one of those agentic programming software, and it just wouldn't work. And then I did some more research, and it turns out they wouldn't work because of the fundamental limitations of the small large language model. So what do I mean by that? Well, the number one thing that limits large language models is their context windows. Famously, small large language models have small context windows. What makes the large language models like Gemini, ChatGPT, and Claude so good is that their context windows are actually gigantic like that. Because small LLMs have a smaller context window, they effectively have a smaller working memory when it comes to completing complicated tasks. And what happens when you have a smaller working memory? Well, you'd probably be better off writing stuff down and loading it in and out of memory. And that's exactly what we do with small LLMs to make it agentic. Now, this isn't something I invented. Actually, I was watching a YouTube video where they mentioned a Chinese research article where they implemented this, and they were able to get I think they were working with 100K context window, and they were able to solve problems that would have taken 1,000,000 contexts. And I'm like, well, that means I can take a 32K context and expand out to 320K, which would be perfect for my needs. It might be a little slow, right? But it'll work. And then I started actually trying to find solutions for that, and I really couldn't find that many. So I ended up building my own. which is a Python wrapper around an open API endpoint that calls a local LM Studio model and then forces that model through the Ralph loop. And through the Ralph loop, it also, reads, evals, prints, and then loops. So it makes a plan, writes the code, tests the code, debugs the code, and then it doesn't stop until it's done or it hits its maximum of iterations. And it kind of works, still kind of iron out the bugs, but slowly making progress. And I've made enough progress that I felt like sharing it with you guys. So I've been working on this for a few weeks and it works, but it also kind of doesn't. I'm hoping I can get some other people's opinion. I talked to an associate of mine and he pointed out that I was trying to do this entire job in one go. And what he suggested was me going back and breaking up the task into a series of smaller lists. So smaller to-dos. And I started implementing that and actually made a lot of progress. Went from working 3 out of 10 times to about 5 out of 10 times. So I'm hoping maybe I could get outside input of what else we could try to get this to work some reliably. I would really like a small agent to just try writing some code in a local environment. And it doesn't matter if it does it slowly, as long as it doesn't take too many resources and you can just forget about it. That would be extremely useful. So behind me is Google Anti-Gravity, and I have an old Ralph loop that needs some cleaning up. So we'll go ahead and clean it up real quick and then we'll do our first test run. There should be a full cleanup script that cleans the Ralph workspace. We're also going to just do a quick arm.rf. All right. So the way it works is you should be able to run Ralph.py right here, pass it a goal, and then it starts, coding, planning, doing all that good stuff for you. Let's give it a basic problem. We do a Python 3 Ralph.py goal, and on the back end of this is a LM Studio server. So let me show you that real quick. And this LM Studio server is running a 7B model with a 64K context window. I've tried to do 4B models, but they tend to lose their place in achieving their objective even faster than the 7B. And 14B is too slow for me to fully test with, right? I'm limited on resources here. I'm trying to get away. I'm trying to make the little I got go a long way. So let's see. We go ahead and issue Ralph.py. We pass our goal and we give it a second. Notice that we now have a Ralph workspace with a logs folder and several other folders that should be created. And we watch the log output of the Ralph.py. You see immediately we get stagnation from the model. But we did list our file system right here. So generally within a few turns, it actually starts spitting out files. And there we go. Now we have a log file, which is actually very useful for troubleshooting where inside of the loop Ralph got held up at. And you'll notice there's several log files in JSON, and these log files basically track Ralph's current states. When you go to main.py, you'll see it starts with a main function, and then it's trying to make a math engine. And so right now, Ralph has some features. It has diff management. It has multiple memory state managements. It has like rules, which are basically system prompts. It has a task memory, which is a series of to-do lists. It has a phase memory, which is, where exactly it should be focusing its current context. It has a goal memory, which is like a series of objectives it needs to achieve overall. Well, all this architecture is so that when you ask it to create code for you in Python, it just creates the code. Well, it implements a plan for the code, writes the code, debugs the code in a Python virtual environment, and then stops. And this process would take a while with a small model and limited resources. Like some of these turns take 1 second, but if you scroll back through, you'll see some turns take, 5, 6, 7 seconds at a time. It's not necessarily, this is like a 4 second turn. It's not necessarily a fast process, 8 second turn, right? But if you could get this running, you could run a 7B model on a regular, $500 or $600 gaming laptop. You could grab one of those from a pawn shop or from eBay, put it in a back closet somewhere, and then have a very cheap automated coding agent running 24/7 on your different code bases. And once you got Ralph reliably spitting out code, you could have something like anti-gravity just drop objective or spec files in Markdown and have Ralph work away. And if Ralph can't solve a problem, well, that's when you pull out a bigger model. And the whole idea behind this is that it's going to slowly save you context costs. Again, I've been able to get pretty far just vibe coding this, but I feel like I've hit a point in the code base where things are just, I need expertise. So maybe somebody else can build off of this. We can get the architecture down and go from there. Or I'll keep working on it. I feel like this is a problem I thought I could solve within a couple of weeks, and it might take months, or maybe even a year. But it's a fun challenge. All in all, that is it for this idea. The source code will be available at the bottom of this video for you guys to play with. You're going to need a open API compatible endpoint to point Ralph to. When you first run the script, it's going to ask you for that endpoint if you don't already have it configured. But there is a config.py file that you can go in and manually set your endpoint to, right? Something I haven't tried yet is actually, because it's open API compatible, I could technically use like ChatGPT or something like that and slide that into Ralph's thinking just to test the logic of the script. Oh, anyways, it's something worth thinking about. As always, if you enjoyed this content, please hit the like button. If you'd like to see more, please subscribe. Otherwise, stay blessed, boys. I will see y'all next time.